Okay, so for lecture 2, we are going to continue with the 1.2 complex number, which is the learning outcome is for D, to determine a complex number in polar form, where Z is equal to R multiplied with cos theta plus I sin theta. And R must be more than 0 and theta is in between negative pi to pi. Okay, complex number can be written in two forms. The first one is Cartesian form, which is z equal to a plus bi. And then the second one is polar form, z equal to r multiplied with cos theta plus I sin theta. Okay, so how can we return this complex number in polar form? So let's say z is equal to a plus bi. So we can sketch or draw the Argand diagram by using the same as xy coordinate. So we assume the real of z is the x coordinate, the y of z is the imaginary, and then we just have to plot. So for z, the value of real is a, so it should be on the real axis, and the value of b, the value of imaginary is equal to b. So the point is here. So this point AB is the representation on the plane. So we can have the theta from the real axis. This is the angle between the real axis and the line of point, and then this here is the modulus of z, which is the hypotenuse of AB. So modulus is equal to what? So it's equal to the length of OP. So how can we calculate the length of OP? We use the formula square root of a squared plus b squared. How about the argument, the theta? So basically the formula is equal to arctangent of b over a. So we have this angle, so the angle can be found by using the formula of tangent. So opposite over adjacent. But argument of z is the angle measured from the positive x-axis. So means that it's either in an anti-clockwise or clockwise manner. Do you understand? So let's see the next step. So for example, so we have 4 quadrants in trigonometric. So for the polar form, the theta should be in between negative pi to pi. So the first quadrant, this is the first quadrant. So we have the theta here, and then it's directly by using the formula theta equal to arctangent of modulus b over a. Obviously this part will be positive, because both real and imaginary is positive. And then for the second quadrant, so the theta we want to find is actually from the real, positive real axis. So from 0 to this line. But in trigonometry, we only can find the angle for this part. How? By using the same formula arctangent of b over a. And then this value is negative for the real one. So that's why we have to put the modulus here. So everything will be positive. Why pi minus arctangent of b over a? Because we want to find the argument here. So the total angle pi minus this angle here, alpha. That's why this angle is equal to arctangent of b over a. And then for the third quadrant, so here our angle should be from the positive real axis. So this is our angle. So how to find our angle? The same as the second quadrant. So the second quadrant here and the third quadrant is here. We can find the angle here. Let's say it's alpha. So to find the angle of the argument of z, what we do is we apply the formula of arctangent of b over a minus pi. Okay, it's actually pi minus alpha, but because it's opposite direction, it should be negative. That's why we take this formula. Okay, so this is for the third quadrant. The fourth quadrant, so this is our angle. So directly from the x-axis. So from the x-axis here, we can directly find by using the formula of arctangent of b over a. Both will be negative and negative, so automatically it will be positive. But we have the sign negative here. Why? Because it follows the clockwise direction. Okay. So this side is the anti-clockwise. This side is clockwise. Clockwise we have negative value. Okay, polar form of complex number. The Cartesian form is z equal to a plus pi. So it's represented by the point a, b. Okay, so on the diagram, Eigen diagram, so this is how we sketch the point. So we have this point a, b, and then we have the modulus here, and we have also the argument. So the argument here. So from the diagram, we know that a over r equal to cos theta. Why? This is the formula of trigonometric. So a over r is for cos, and then we can rewrite this as a equal to r cos theta, and then b over r equal to sin theta. Opposite over hypotenuse is equal to r sin theta. So we can rewrite b equal to r sin theta. So these two equations can be written in the form of z equal to r cos theta plus I of r sin theta. This one is our a and b, replacing the a and b here. So by factorizing the r, what we will get is z equal to yes, r multiplied with cos theta plus I sin theta. So this is our polar form. So let's do some example. The question here asks you to represent the following complex numbers on Argand diagram and find its modulus and argument. Express the complex number in polar form. So this question have 4 steps. The first one is to, yes, represent in Argand diagram, and then find modulus, and then find the argument, and the last one is to express in polar form. Let's do the questions. Okay, so for question A, z equal to 2 plus 4i. So we have our A here and B. So let's sketch on the diagram. So both are positive. So all will be in the first quadrant only. So this is our point 2, 4. So how to find? Finish for our Argand diagram. So we just have to label where is our modulus. No, we don't have to label the modulus. We just have to label the point here. Don't forget to label real and imaginary on the axis. Okay, to find the modulus, apply the formula, which is the square root of 2 squared plus 4 squared. This is the formula of hypotenuse, right? So we will get the answer 2/5. And then for the argument, so the argument here on the first quadrant, directly we will use the formula arctangent of 4 over 2. So the first quadrant, so the answer should be directly in radian form 1.107. Why radian form? Because the range is in between negative pi to pi. Remember that. So the argument is equal to 1.107, and the final one they ask you to write down in the form of polar form. So the answer should be z equal to r, which is 2/5 multiplied with cos of 1.107 plus I sine 1.107. Okay. So for question B, so to sketch the Argand diagram, so our value for real here is positive but not for the imaginary. So it should be to the right and to the bottom. So our graph will be look like this. So please find the P. So it will be around here. So our angle should be from the x-axis. So this one is our angle, which is the argument, and then this is our modulus. Okay, so this is the point 2, -4. And then the next question is to find the modulus. Apply the formula. So we will get the answer the same. Why? Because the magnitude is the same. And then how about the argument? So argument, because it's opposite direction, clockwise direction, so it should be negative of arctangent 4/2. So 4/2. So it should be 4/2, right? But remember, we have the formula modulus, so the negative will be forfeit. So the answer here is negative of 1.107 radian. So the last question is to write down the answer in polar form. This is the answer. So z equal to 2/5 multiplied with cos of negative 1.107 plus I sine of negative 1.107. Okay, for question C. So I think you can try on your own to sketch the graph. So it will be on the second quadrant. So what is our R? What is our argument? So for R, directly we apply the formula square root of a squared plus b squared. So we get square root of 8, which is square root of 4 multiplied with square root of 2. So we will get 2/2. For argument, so since it's on the quadrant, the second quadrant, so what we should do is to find the alpha first. So how to find the alpha? This one is actually arctangent of opposite over adjacent. So 2/-2. But don't forget we have the modulus. That's why we have arctangent of 2/2. And then what we want to find is the argument is here. So argument is equal to the total angle here, pi minus the alpha. That's why pi minus arctangent of 2/2. So the answer here is 3π/4. So we can write down the exact value, or if we cannot write down in exact value, we can give your answer in points, in decimal. Okay, this is the answer, the final answer. -2 plus 2i can be written as equal to 2/2 of cos 3π/4 plus I sine 3π/4. Okay, so question D. So this question is in the third quadrant. Why? Because we have negative real and negative imaginary. So sketch this graph on the third quadrant. So we will have this as the results. And then we want to find the R and the theta. So directly plug in into the formula. For the R, we get 2. And then for theta, so most of the students have the problem with the theta. So for this theta, what we want to find is this angle, right? So this angle, what we want to find is this angle theta. So we can find this angle alpha. So how do we find the theta? We have to find the alpha. So in this direction, it's a clockwise direction, it should be negative. So if we follow the step, this alpha is actually arctangent of 1/3, right? So for positive, because we have the modulus. And then we want to find the theta, we put negative of pi minus arctangent 1/3. But after expanding the negative, we will get arctangent of 1 over sec 3 minus pi. So the answer here is negative 5 pi over 6. So substitute all the values into the equation, into the formula form. So we get the answer negative sec 3 minus I is equal to 2 multiplied with cos of negative 5 pi over 6 plus I sine of negative 5 pi over 6. Okay, we are done with we are done with the complex number. Yes. Thank you.